Hello everyone, my name is Amy Barr and I currently work at West Suffolk College and I currently work in the STEM Innovation Centre for engineering and I'm an engineering lecturer. So today guys, I am going to be talking to you about the principle for the conservation of momentum method. So let's get started. Now, when we're looking at the principle for conservation of momentum, as are most things in mechanical principles, it was actually developed from one of Newton's laws. He stated basically that when we have the total momentum of a system in a given direction, which remains constant, providing that the masses remain the same and they are in the same direction with no external forces on them, such as friction or wind, this would then incur that if we have two objects, for example, travelling in the same line and direction, one behind the other, if they then collide, they will then move forward with a combined speed. This is then shown in this diagram here, where we've got a smaller ball colliding with a larger ball, that when they're combined, they will then have a combined moving speed going forward. Now we can use this and we can put this into an equation. The equation is then we've got our mass 1 from that first ball combined with the velocity of that ball that it's travelling. In this example, we've got 5 meters per second. We can then add that to the mass of the second ball, again the velocity of the second ball, and that will then both resultant together the combined masses of both, and that will then give us a new velocity of those two combined masses. Now in this video I'm going to give you an example of how we can actually use this in an example question. So if we have an example at the moment of a spacecraft, now we've got a space vehicle that is travelling at a velocity of 3,000 meters per second. It then is separated by a controlled explosion. It separates into two sections. We've got a mass then of 270 kilograms and a mass of 180 kilograms. The two parts then carry on in the same direction with the heavier rear section. However, it's moving a bit slower. It's moving exactly 200 meters per second slower than the lighter section at the front. What we need to do is we need to now determine what is its final velocity. Now guys, before you do anything, I find it really helpful if you always draw a schematic to help yourself out with any question. So I've got an example of a schematic here. So in this schematic, as you can see you have got the combined vehicle at the front, and then we've got our separate sections breaking off with a controlled explosion in the center. So what do we know? When we approach any question at the beginning, what you do, as I've said, you want to draw a schematic for a start, but secondly, we want to identify all the known variables which we can write down because we need these later and they're going to be useful. So what I would do first is I would write down all the variables that we want to find out or that we need to, and then go through the question and use a highlighter to then highlight and allocate these to the all known variables. This will make your life a hell of a lot easier as we go on in the question. And this is a good procedure to do for every question that you do, when especially you have a worded question, because it helps it to break it down. So the first part that we're looking for is what is our velocity? Now, I've got my highlighter and I've now highlighted my velocity 1, which is given in the question. It's telling us that we've got 3,000 meters per second is my velocity 1. Okay, so I can put that down. I then want to find out my mass 1. Now in this question, you would always say that the first mass in the sentence would be mass 1, and consequently in this case is 270 kilograms, as you can see here. So we're going to label that as our mass 1. Subsequently, you would then imagine that the second one is going to be our mass 2, which is 180 kilograms. So we're going to label that, highlight it so you can show where you found it from, and put it and allocate it next to mass 2. Then finally, the only thing we've got left is our velocity 2. Now, yes, in this question, it has given us a value for velocity 2. However, in the question, it states that the rear section is moving exactly 200 meters per second slower than the lighter front section. So this is a bit of a sneaky one because it's not actually giving us the value, but it's telling us of how we can get to that value. And how we can get to that value is from doing our final velocity, so velocity 3 minus that 200. So we can use that. And here I've labelled it as V2 is equal to V3 minus 200. So this is great. We've now got all of our values in our question. Everything's labelled up, and we can then tackle the structure and how we're actually going to go step by step for this question. So for step 1, what we're going to do is we're going to use the conservation of momentum equation, which I've just put in there, which we had on the previous slide also, and we're then going to use that in step 1. Now, as you go forward, I have got in my right top hand corner those values highlighted in yellow, and my schematic, because it's really good just to remember what they are and have them to hand and you can see them. So this first step that we're going to do, guys, is we're going to rewrite the conservation of momentum equation, which we had on the previous slide. What we know from that equation is that momentum is equal to mass times velocity. We know that. We can use that in this question because I'm going to start labelling my two masses as a mass B is then equal to mass A. Okay, so for my mass A, it is then equal to my M1 plus my M2 times V1. I have then also got my mass B, which is equal to M1 times V2 plus M2 times V3. So all I'm going to do now, guys, is just put that into my mass B is equal to my mass A. Nothing new here. I'm just going to write it out fully, which will then give us this equation. I'm going to then use that to go on to my next step. So my next step, we can then start to populate that previous equation that we got from the last slide here with what we do know. Remember that yellow bit in the top right hand corner here? What do we know currently? We know a few things, but at the moment what is important is my V2. Now we know in the question that V2 has told us that it is exactly 200 meters per second slower than my final velocity, which is V3. So I can then substitute V3 minus 200 now for every value that is labelled V2. This will then extend out that equation that you've done, but now it is the equation in its entirety. Okay, so we've got our M1 plus M2 times my V1 is then equal to my mass times my final velocity minus 200 plus M2 times my final velocity. we don't know what my final velocity is, and we also don't know what our V2 is at this stage. All we know is that we know V1. So what we're going to do in the next step, guys, is we're going to begin to factorize this equation and make it so that we can just simply plug in our values. So the way that we do that in step 3 is we can factorize that equation that we got previously. Nothing new here. And the way we're going to do that is we're going to simply look on my right hand side and we're going to factorize out m1. So if we want to factorize m1 out, we then want to times our m1 times v3, and then my m1 times minus 200. That is then going to give us m1 v3 minus 200 m1. You've then got the brackets out of m2 and v3. We can then focus on factorising that last section now. So we then want to see what the common denominators are and begin to factor that last section. That last section being v3. So the way we're going to do that is we're going to look at v3 and we're going to factorise that out. So we can see here that we have got our common denominators of v3 is then times m1 plus m2 because they're added together, and then we have still got our minus m1, but he is out on his own at the moment. Okay, so we've got our final equation that we can then use in the next part of this section. And the fourth part of this section is we're then going to transpose this. I know this sometimes can be difficult for some people, so I'm just going to break it down and we're just going to do it slowly. So when we're factorising, guys, we want to then factorise out for v3 by himself. No new information here, I've just carried the equation across from the previous slide of what we know from when we factorised. I now want to get v3 by himself. So what I would do first is I would highlight the particular value that you need to get so it's clear. The easiest way to then transpose this equation is to then divide both sides by the other part that you don't need in that particular section of the equal sign. In this case, in this equation, it happens to be m1 plus m2. So quite simply, guys, all you're going to do is just draw a line under both sections and then bring down that m1 plus m2, okay? Which is going to look something like this. So all I have done, I have swapped the sides that they are on, which don't worry about it, but it's just the same equation with m1 and m2 on the bottom, as you can see here. Now, what's really good is you're going to take your pen and you can then get rid of the parts of the equation that then occur twice on the top and the bottom, because why? They cancel out. You guys know this. So all we're going to do is just take your pen, cancel the top, that then is repeated also on the bottom. There we go. It doesn't happen on the other side. So here you can see that yes, we have got m1 and m2 at the bottom. We have also got it at the top. However, we've got to be careful because v1 is also attached to that and we can't detach that. So therefore you can't cancel out that and that because it has got v1 attached in its own brackets. We can only then apply it to this side here because they are in their own brackets. This is really good, guys, because it means we can then get v3 by himself. Once we've cancelled out those numbers, we'll then get v3 is equal to that top line of m1 plus m2, then times our v1 plus 100 m1, all over m1 plus m2. This is awesome. Okay, so we can then really get to the last bit of this equation where we're going to find it useful to put in our values. So the last part, guys, is we simply have to substitute all of those values that we know into that equation which we have just derived. So transporting that across from the previous slide, making sure that we've got our workings all the time labelled. The easy bit now is just looking in the right-hand corner for our values that we know. We can then pop them into that equation. Really easy. So I know that my M1 is 270. I know that my M2 is 180, not 150. Times 3000, which is my V1, plus then we have got 200 times my M1, which is 270, all over 270 plus 180. Now, when you guys type it into your calculator, you should be able to get 2,920. Now, we've got V3, and that's awesome because what we know now is that from V3, we can then work out V2. Because remember, it has told us in the question that V2 is 200 meters per second slower than V3. So all we have to do at this stage is simply detract 200 from our V3. So quite easily, all we've got to do is 2,920 minus 200 will give us our V2, which is 2,720. So looking back on our question, we can then quickly label our schematic. So initially we have been told that the initial combined velocity is 3,000 in the question, which I can label my diagram now. I have also now worked out what my V3 is from the equation that we first did, which happens to be 2,920 meters per second. Now, in the question, it clearly states that the second part is the heavier part, is travelling 200 meters per second slower than the lighter front section. Okay, so we worked out that because you've just simply got to get rid of 200 from your V3, which is going to give us a value of 2,720. So we have worked out all of our values now, and hopefully you guys have a little bit of a better understanding of how we can actually apply the conservation of momentum equation and how we can find it useful when we have an example travelling from two vehicles in the same direction in this case. I hope you guys enjoyed the video, and please leave me a comment if you found this useful. Thank you, and look forward to seeing you on the next video. Bye!